Okay, class, in this lesson, you are going to learn to add and subtract radical numbers. So let's go ahead and get started with the first example. Here we are looking to find the sum of the square root of 2 plus 3 square root of 2. Okay, now before we get started, there is something we need to recognize, and that is in front of this first radical sign, there's an implied number, and that number is the number 1. Okay, we don't write the 1, but it's implied that it is 1. And so what we have here is 1 square root of 2 plus 3 square root of 2. That is the same thing as saying 1 apple plus 3 apples. Okay, so 1 plus 3 gives us 4 square root of 2. Okay, now adding those together was pretty straightforward because we were adding like terms. Okay, now in this example, we're now taking the difference, and the same thing applies. We have an implied 1 here in front of the radical sign, and so this just works out as 1 square root of 2 minus 3 square root of 2. So 1 apple minus 3 apples is negative 2 square root of 2. Okay, now let's move on to example number 2. Here we have a situation where we're adding two radical numbers, but the numbers in the radical sign are not the same. Okay, now before we do this problem, I want to make sure that everybody understands what this radical sign means. Okay, when we talk about a square root of, let's say, 4, that is really the square root of 2 times 2, right? Those are the factors of 4. And the factors of 4 are 2 times 2. When you have two of the same numbers underneath this radical sign, you can actually take them out. And when you take them out, the radical sign disappears, and you're left with just one of the two numbers underneath the radical sign. Okay? So let's use another example. Let's say that we have the square root of 16. That is the same thing as the square root of 4 times 4, okay? And since we have two sets, or we have one set of 4 times 4, or two numbers that are 4 underneath the radical sign, we could pull those out, and when we do, that works out to just the 4 without the radical sign, okay? So in this example, square root of 8, we want to think about factors of 8, okay? And the factors of 8 are 4 times 2. And we're going to do the same thing for the next set, and we're looking for factors of 12. Okay, there are two different types of factors. We have 6 times 2 and 4 times 3. We are going to choose 4 times 3 because 4 is a perfect square. Okay, 4 is a perfect square, and we can easily square root that in the next step. And let me show you what that looks like. Okay, now before I skip a step, I want to make sure that we understand how this works. So what I'm going to do is break this 4 down into 2 times 2. Okay, so that this becomes 2 times 2, which is the 4, and we also need to multiply it by 2 again because of this 2. And then in the second radical, we have 2 times 2, which is our 4, and then times 3. Okay, so now you'll see in this first set, we have 3 2's down here multiplied together. We can take 2 out at a time, and so when we do, we're left with 2 on the outside of the radical sign. And since we took out these 2, we're left with this third one, and that stays underneath the radical sign. Can't pull that out until we have another one. Okay, and then in this second set, we have 2 2's over here, so we could pull those out as well, and this works out to 2 square root of 3. Okay, now we cannot combine these two terms because this is like saying 2 apples and 2 oranges. Okay, you can't combine those. If these numbers underneath the radical signs were the same, then we could combine those terms. Okay, so don't let this 2 on the outside throw you off and make you think that you can combine them. All right, so this becomes our simplified answer. Okay, Now let's take a look at this one. We're looking for the difference of square root of 8 and square root of 50, okay? So again, we want to break square root of 8 down into factors. So this is 4 times 2 minus, and the factors of 50 are 10 and 5, which we could use, but the better set of factors are 25 times 2. Now why 25 times 2? That's because 25 is the largest, or in this case, the only perfect square that happens to be a factor of 50, okay? Now watch what happens. In this radical, we have a 4 underneath the square root sign. So the square root of 4 we already know is 2. So this becomes 2 square root of 2, okay, minus, and the square root of 25 is 5, right? 5 times 5 is 25. So taking the square root of 25 is just 5. So then this works out to 5 square root of 2. Okay, now we have 2 square root of 2 minus 5 square root of 2. This is like saying 2 apples minus 5 apples, and that works out to negative 3 apples, or square root of 2 in this case. Okay, so let's move on to example 3. Okay, what is the sum of square root of 16 plus square root of 25? Okay, so if you don't recognize 16 and 25 as being perfect squares, we can go through the steps of finding factors, right? So square root of 16 is 4 times 4, and the square root of 25 is 5 times 5. Since there are two 4's being multiplied together underneath the radical sign, we could pull those out, and all we're left with is 4. And then the same thing with the second one. We have two 5's being multiplied together underneath the radical sign. So we can pull those out, and we get 5. And therefore, 4 plus 5 is equal to 9. All right, now let's take a look at this one. What is the difference of the square root of 49 and the square root of 81? So again, if you don't recognize that these are perfect squares, we can go through the steps of finding the factors. So 49 is the same as 7 times 7 minus, and the square root of 81 we should recognize is 9 times 9. Okay, now we have two 7's underneath the radical signs being multiplied together. So those can come out, and we're just left with 7. Same with the next one. We have two 9's underneath the radical sign. Those can come out, and we're left with 9, and therefore 7 minus 9 is minus 2. All right, so let's increase our level of difficulty and take a look at the following. We have the square root of 18 plus the square root of 16 minus the square root of 27 plus the square root of 32. Okay, so the strategy in doing this problem is no different than what we did earlier in the previous examples. We're going to simplify each term and then figure out if there are any terms that can be combined together. Okay, so square root of 18 has two different factors, 6 times 3 and 9 times 2. We're going to use 9 times 2 because 9 is a perfect square. Square root of 16 we already know is 4 times 4, so that works out to just 4. And then the square root of 27 is really 9 times 3. And then the square root of 32 has 8 times 4 as a factor, but there's actually a better one, and that is 16 times 2. Okay, we're using 16 because 16 is the largest perfect square that is a factor of 32. All right, so now we've got square root of 9. That works out to 3, so that could be pulled out. The 2 stays underneath the radical sign, plus 4, so nothing to do there. Minus, we have a 9 underneath the radical sign. That is a perfect square, so we could pull that out, and that works out to 3. Square root of, and the remaining 3 stays underneath the radical sign. Plus, we have a square root of 16. That's also a perfect square, so that comes out to 4 square root of 2. Okay, now we have 4 terms that are simplified, and now we're going to look and see what terms can we combine. Well, we see that we have a 3 square root of 2 and a 4 square root of 2. Okay, those are the only 2 terms that we can combine. So 3 square root of 2 plus 4 square root of 2 gives us 7 square root of 2. And then we leave the rest as is. And this becomes our final answer. Okay, let's move on to another example. So here we've got square root of 72 minus 3 square root of 60 plus 4 square root of 32. Okay, again, we're going to work through each term and simplify them. So the first one is the negative square root of 72, and the factors of 72 with the largest perfect square would be 36 times 2. Okay, it's tempting to say it's 9 times 8, where 9 is a perfect square. However, there's a larger one here, and this is 36 times 2. Okay, so we're going to do minus 3 times, factors of 60 are 10 and 6, 2 and 30, 3 times 20, but the best factor with the largest perfect square would be 4 times 15. Okay, and then the last one, plus 4 square root of 32. We've already worked with this. The factors with the largest perfect square would be 16 times 2. Okay, so let's go ahead and simplify this. The square root of 36 here is 6, so we're going to pull that out and leave the 2 underneath the radical sign. Minus 3 times, we have a perfect square here of 4, so square root of 4 is 2, so we're going to pull that out, and we're left with square root of 15. And then 4 times, we have a perfect square of 16, so the square root of that is 4, so that comes out as 4, and we're left with square root of 2. And now if we look at all 3 of these terms, we see that this term and this term can be combined. Okay, so before we do that, let's go ahead and simplify this. This works out to negative 6 square root of 2 minus 6 square root of 15 plus 16 square root of 2. Okay, now we can combine these two terms. Negative 6 square root of 2 plus 16 square root of 2 works out to a positive 10 square root of 2. And then we write the remaining term, which is 6 square root of 15. And we can no longer simplify this further, so this becomes our final answer. Okay, and then one last example. We have this negative square root of 100 minus 5 square root of 45 minus 2 square root of 125. Okay, so let's go ahead and simplify this. This is going to be negative square root of 10 times 10 minus 5 times the square root of 9 times 5 minus 2 times the square root of 25 times 5. Okay, square root of 10 times 10, we have 2 10s underneath the radical sign, so we could pull that out as a 10, so that just becomes negative 10, minus 5 times 3, because of this 9 here, it's a perfect square. We can pull that out, and that becomes 3, and the 5 remains underneath the radical sign, minus 2 times the square root of 25 is just 5, so that becomes 2 times 5, right? Square root of 5, okay? The remaining 5 stays underneath the radical sign. So let's go ahead and simplify this. This is negative 10 minus 15 square root of 5 minus 10 square root of 5. Okay, and then the last step, we see that these two terms are like terms, so we can combine those, and we get negative 10 minus 25 square root of 5. And that is our answer for this example. Okay, so hopefully that made sense. If any of this was not clear or confusing, please go back to the beginning of the video and listen to it again. Thank you.